from Unit 7, so the second part of the transformations, okay? So, as we go into this, the first screen here is just kind of a warm-up. We had two warm-up screens here, screens 2 and 3, so we'll go through those. Make sure we understand and know the graphs, and then on screen 4, and then 5 through 8 were the core portion of what we were trying to learn for this lesson. So, if you start here, what you want to see first is just kind of all these different functions. So what happens? So if we add or subtract a number on the outside of the function, okay, what that's going to do is that is going to shift our function up or down. Okay, so shifts the function up or down. Right. If we have a negative on the inside, so that negative, notice that negative is on the inside. So in other words, we're multiplying by a -1 on the inside here. Then what that's going to mean for us is that our graph is going to reflect over the y-axis. So there you go. All right. If we add or subtract a number on the, flip those around, on the inside, add or subtract a number on the inside, which would look like this. So if we do that, then what that's going to mean for us is, that graph is going to move right or left. So there's the right or left. Okay, if we have a number that is less than 1 on the outside, that is going to be a vertical compression. The graph looks like it got wider, so that graph is going to be wider. So let's find that one. Multiply the parent function by a number less than 1. There we go. All right, if the a value there is greater than 1, then that is going to be a vertical stretch, which means that that value is going to be multiplied by a number greater than 1. And then lastly, if we multiply by a -1 on the outside, like this, that is going to reflect over the x-axis. So there we go. All right, as we went to screen 3 here, we're trying to do everything based on this x squared, okay? So in other words, what would we do to write these equations? So x squared, if we wanted to go up 2, we would add a 2 on the outside. Remember, we put a number on the outside, that moves our graph up or down. So here we want to go down 7, so we subtract 7 on the outside. Okay, if we want to go right, remember the right and left are based on the inside, but it goes the opposite of what you would think. So to go right 1, we're actually going to do a -1. And then we want to go left 4 here. What we're actually going to do is we're going to do this as an x plus 4. And then, still squared since we're comparing everything to this x squared. Okay, we want to go up up 4 and right 3. So we're going to go x minus 3 for the right 3 squared, and then up 4, so plus 4. So that's what that should look like. Left 1 down 9, so to do that, I'm going to go y equals, and then I'm going to do x plus 1 to go left 1 with the squared, and then down 9 minus 9 on the outside. Reflect over the x-axis. Again, how do I reflect over the x-axis? I need the negative on that outside, so that should just look like that. And a vertical stretch of 8 would just mean we'd have an 8 in front of the x squared for that vertical stretch. Okay, so that's really just a review from lesson 30. Screen 4 is just, hey, you need to know these parent graphs. So it's worth your time to make sure, do you know the name of the graph in the equation? Can you go back and forth between all of them? So when you see these graphs, when they've had transformations, that you can manipulate them the right way. So now let's focus today on just what is our content for today. And it's pretty short. So basically asking you to do two things in two ways. Given an equation, can we identify what type of graph it is, the transformation, and regraph it? Given the graph, can we identify the transformation and draw the equation? So we'll do screens 5 through 8, and their asynchronous work is to do 10 through 14, so make sure you do those. So here we see that this is at x squared plus 2, so the first thing you want to do is identify the parent function. Well, we see that x squared, we should know that's quadratic, which means we should know that it should look like that orange graph. So then what happens? Identify the transformation. Well, that plus 2 on the outside is going to shift the whole graph up 2. So we move up 2, regraph, that's what the blue line is, and that's all you're doing. So over here, I see this is x to the third, so that parent function, right away I'm thinking, hey, I know what that is. It's got to be, since it's x to the third, it's going to be x cubed, or x to the third power. So what are my transformations? So when I look at my transformations here, I see the negative on the outside, so that's going to reflect over the, since the negative's on the outside, it's going to reflect over the x-axis, and then I have that -3 on the inside, so that's going to shift me right 3. Okay, so we just want to do both of those things. So instead of at 0, 0, we're going to go right 3. And then instead of my graph kind of going from bottom left to top right, it has to reflect over the x-axis. So from here, it's actually going to go kind of top left like this, through and down to bottom right like this. Okay? So that's what that should look like. So then there's an example for you to try here. So you see this graph right here. Hopefully right away you're like, hey, I know what graph that is. That parent function is going to be x squared, or the square root of x. So it's going to be f of x equals square root of x, which, hold on, actually, I'm just going to type that out. So f of x equals, and then the square root of x. That minus 1 on the inside, that transformation, so what is that going to do? It's going to shift our whole graph to the right 1. Okay, so now what do we do to graph this thing? You're going to right 1, put the point there, and then from there we're going to draw our sketch. So again, it should go out and to the right. Since it's a square root graph, this is what that graph should look like. So that's kind of our transformation. All we did from the parent graph, which would be, this, was we just went right 1. Okay, so otherwise that graph looks basically the same as one transformation. Okay, so those were, you had the equation, you draw the graph. Okay, now let's do it in reverse. So here's the graph, let's get the equation. So the first thing to do is identify the center point. So in this case, you should look at that graph and say, hey, that's an absolute value. So hopefully you recognize it's this shape. Then you say that one left 2, so negative 2, and then we do want to check the slope. So from here we go up 1, right 2. Normally you should go up 1, right 1. So because we went up 1, right 2, that means there has to be a compression of 1/2. So we had a compression of 1/2, and we went left 2. So there should be an x plus 2 here on the inside, then a 1/2 on the outside. Because remember, we put that number on the outside for the stretch of compression. In this case, it was the compression, so we had the 1/2. In other words, just like the slope. So let's look at this one. So right away you should say, hey, I know that. That's a cubic function. So the parent graph should be f of x equals x to the third. What's the transformations here? Well, where's my vertex center point, right? My vertex center point is right here at 1, negative 1. So what did we do? We went right 1, down 1. So I'm going to say that, hey, I know my transformation. I went right 1, down 1. And then I check for the slope, but here I go up 1, right 1, so it's directly on it. Down 1, right, left 1. So nothing else happened. So now I need to go down to my equation. So I'm going to do f of x equals, okay, if I went right 1, then in the parentheses I'm going to do x minus 1 to the third. And then I need to go down 1, so a minus 1 on the outside. All right, and then just for practice, that was what we did here with 8. So what's this parent function? Well, it's this kind of horizontal squiggle, as we called it. So that parent function should be f of x equals, and then it's the cube root of x. And actually, I'm not 100% sure how to type that in, so I'm going to just write it in, actually. Apologize. So f of x equals, and then it's going to be the cube root of x. And then, what's my transformation? Well, what did it do? It should be at 0, 0. It went right 2. So that's my transformation. We went right 2. Okay? All right, so what's my equation? So now let's do my equation. Well, it's going to be f of x. Now, there wasn't any shift, the only shift was right 2, right? Because look at my slope. I went up 1, right 1. I went down 1, left 1. There you go. There was no other changes, no reflection. So all I need to do is show that. So I do my cube root here with my x minus 2 here. And that would be right 2. And that's it for today. So basically just noticing, hey, given the equation, can you say the transformations and draw the graph? And then given the graph, can you say the transformations and write the equation? So going both directions. Please make sure you do screens 10 through 14 for your asynchronous work. Hope this helped.